In this video, we demonstrate ASTER. Agentic text-to-SPARQL with task skills, autonomous exploration, and refinement. ASTER enables LLM agents to translate natural language questions into executable SPARQL queries over knowledge graphs. It is powered by modular task skills that support entity and relation discovery, autonomous graph exploration, query construction and execution, result validation, and iterative refinement. The system's source code is publicly available on GitHub under the Apache license. ASTER can be used in two ways. Interactively through the conversation panel of an agent runtime such as OpenCode, or programmatically through a Python script that communicates with the OpenCode server and saves the relevant outputs to files. We will begin by demonstrating the interactive workflow. Let us now move to the OpenCode interface. We begin by entering the natural language question. Which movie released in the last 10 years has won the most Academy Awards? The agent first loads the relevant task skills, including the main text-to-SPARQL skill. It then creates a plan to identify and resolve the entities and properties mentioned in the question, explore the knowledge graph to discover the appropriate path patterns, construct and execute a SPARQL query, and validate the returned results. As you can see, the agent first invokes the Wikidata search skill with terms such as award received, publication date and film to identify the relevant Wikidata entities and properties. Using the identified entities, classes, and properties as seed nodes and edges, the agent then invokes the graph exploration skill to examine how the relevant facts and relationships are modeled in Wikidata. Based on the graph exploration results, the agent either confirms its initial assumptions about the graph patterns needed to answer the question or develops alternative strategies. In this demo example, the agent verifies that the selected properties for awards received and release dates are correct. However, it determines that a broader strategy is required to capture the different types of Academy Awards. It also observes that a movie may have multiple release dates, which could introduce duplicate results and inflate the award counts. To avoid this, the agent uses the earliest recorded release date for each movie. Based on the current system date, the agent automatically calculates the appropriate 10-year time frame and incorporates it into the query. Finally, the agent executes the final SPARQL query and identifies La La Land as the correct answer based on data in the Wikidata snapshot provided for the wiki-based knowledge graph question answering challenge. The conversation history provides a complete record of the agent's workflow, including the skills it invoked, the intermediate actions it performed, the results and observations from those actions, and the reasoning behind agent decisions. Although we do not demonstrate it here, users can also provide human-in-the-loop feedback to guide the agent toward a particular strategy or request further refinements, as would often be required in real-world scenarios. Now, let us demonstrate how to run the same workflow programmatically using a Python script. As input, we provide a file containing the natural language questions, specify the question IDs to process, and define the directory where the generated outputs should be saved. As you can see, the Python script has started an OpenCode server instance, created a new agent session, and submitted the selected question for processing. Once processing is complete, the script generates 4 output files. The SPARQL query, the final answer, a raw session log containing the complete details of the agent's execution, and a formatted human-readable version of the session log. Now, let us briefly look at the generated outputs. The session trace.md file provides a formatted human-readable version of the agent session in Markdown. It allows users to inspect the invoked skills, tool calls, selected reasoning snippets, and corresponding tool outputs. The session.log file contains the raw, machine-readable session trace in JSON format. It captures the complete execution details, including elapsed times, token usage, intermediate actions, and other session metadata. Finally, the sparkle.json file contains the final SPARQL query generated for the natural language question, while the answer.json file contains the corresponding answer obtained by executing that query against a knowledge graph. Thank you for your attention and we welcome you to try out the demo.